Bismillahirrahmanirrahim. Welcome to the first part of 18th lecture of Statistics and Probability Theory. In previous lecture, we have studied uniform distribution. Uniform distribution can be split into discrete and continuous. If your random variable is discrete, then the distribution will be discrete uniform distribution, and if the random variable is continuous, so the distribution will be continuous uniform distribution. In case of discrete uniform distribution, probability mass function will be f of x is equal to 1 over k, and mean is equal to 1 over k summation I is equal to 1 till the value k x I. So this is the mean of the discrete uniform distribution, whereas variance is equal to 1 by k summation I will be equal to 1 till k, and summation is applied to this is x, this is x, I is in subscript minus mu whole square, where mu is equal to 1 over k summation xi. So this is the case of discrete uniform distribution. In case of continuous, f of x will be equal to 1 over b minus a, where x is between a is less than equal to x, less than equal to b, and mean is equal to, in case of continuous uniform distribution, a plus b divided by 2, and variance will be equal to b minus a whole square divided by 12. So this is the case of uniform and discrete uniform distribution. Topic of today's lecture is normal distribution. We were going to study some important features of normal distribution in this lecture. Introduction. It is sometimes called the bell curve. As you are familiar with the shape of the bell, it is something like this. This is not the perfect one, but it is something like this. This is the shape of the bell, and something it has here. So basically this curve shape is called the bell shape. So normal is also called the bell curve. It is also called the Gaussian curve after the mathematician Carol Frederick Gauss. Strictly speaking, it is not correct to talk about the normal distribution since there are many normal distributions. There are many normal distributions because the normal distribution has two parameters, which is mean and standard deviation. Whenever the mean and the standard deviation change, we will have the some new shape of the normal distribution, but obviously it will be the bell shape. So here are some normal distributions. This green one, this is red one, and this is, I guess, the black one. Yeah, this is the black one. So all these three normal distributions differ whenever their mean and variance is very different. So what this figure is saying, the green leftmost distribution has a mean of -3 and a standard deviation of 0.5. So this one has mean -3, its mean value is -3 and standard deviation will be equal to 0.5. In case of red, the middle one, so this is the red one, and it has a mean of 0 and a standard deviation of 1. The distribution of black, the rightmost, so this is the rightmost, this is the black color, and it has the mean of 2 and a standard deviation of 3. These as well as all other normal distributions are symmetric. Later on we will discuss what does this word symmetric means with relatively more values at the center of the distribution and relatively few in the tails. Features of normal distribution. Normal distributions are symmetric and normal distributions are symmetric around their mean. So basically, this is a bell curve distribution. It's not so good one, but this is the bell curve, and symmetric means that this distribution has mean here at the peak, and we have 50% data or information before this mean and 50% after this. So this is called the symmetric, and this normal distributions are usually symmetric around their mean. That is 50% data is before the mean and 50% data above the mean. The mean, median, and mode of a normal distribution are equal. So this is a main feature of the normal distribution, that mean will be equal to mod. This one represents the mod, and it will equal to median, and this one represents the median. So mean will be equal to mod and median, so it will lie same at the peak of the distribution. So this one is the peak and these are the tails. These are the tails. The area under the normal curve is 1. So total area under this normal curve at this probability density function, because this is continuous probability distribution, so that's why we will call it probability density function, and total area under the curve should be equal to 1 because the total probability is always equal to 1. Normal distributions are denser in the center and less dense in the tails. Normal distributions are defined by two parameters, the mean and the standard deviation. 68% of the area of a normal distribution is within one standard deviation of the mean. Approximately 95% of the area of a normal distribution is within two standard deviation of the mean. This one means that mu minus sigma and mu plus sigma. This is the interval, and this interval will contain the 68% of the data. If we draw the normal curve, this should be like this, something like this. And let me change the color of the ink. This one. Okay. So this one is the mean. And let's suppose I represent the mu minus sigma with the color orange. For this we will use the orange color, and mu plus sigma blue. For lower limit we will use orange color, and for the upper limit we will use the blue color. So here we will have the upper limit, basically obviously mu plus sigma, and now we go for the orange color. So this is the orange color. So now what they are saying? They are saying oh should be blue. So what they are saying that the total area between this particular interval mu minus sigma and mu plus sigma is 68%. Here we have the mu, which is mean, and this one should be black. Total area, this total area, we should use the eraser here. Now, so total area between these 2 points is 68%, that is 0.68. So this is 68%, 0.68. So they are saying that 68% of the area of our normal distribution is within one standard deviation of the mean. So this is one standard deviation of the mean. And next they are saying that approximately 95% of the area of a normal distribution is within two standard deviation of the mean. When they are saying that within two standard deviation, it means mu minus 2 sigma and mu plus 2 sigma. So they are saying that whenever you draw this in this way, that this one is the lower limit and this one is the upper limit, but this time the lower limit is 2 times the standard deviation, that is mu minus 2 sigma and mu plus 2 sigma. So it will contain 95% of the area of a normal distribution, that is 0.95.